mics and all that.
I definitely have audio.
It's from India. So, Heitlinger's not coming.
He's not going to be here tonight.
Okay.
So I'm afraid.
You know, he was at our very Please come in and take a seat. And the panelists on the stage, please. Welcome and thank you for attending. This is our 11th annual conference like this, and we appreciate your attendance. This is a really interesting topic in the era of climate uncertainty in Southern California. Is Southern California ready to invest in sustainable local water resources? This event is put on by the American Academy of Environmental Engineers and Scientists, specifically the Seminars and Workshops Committee. And we have the co-chairs of that committee. It's a national committee, but we happen to have the co-chairs here tonight. Sharon Yin, stand up, Sharon, from Orange County Sanitation District. And can everybody hear me okay? And Wendy Wirt from LA County Sanitation Districts. Thank you to both of you for developing such an interesting and important topic. On the trip up here on the freeway, I had some time to reflect. I had a couple of hours actually, and I reflected on the theme of this program, reflecting on especially the preamble portion of it in the era of climate uncertainty. And I got to thinking, you know, that preamble probably needs to precede almost everything that we do these days in the wake of the recent IPCC report. We don't have much time to start thinking differently in everything that we do. And I'll give you a couple of examples. So in the time of climate uncertainty, how do we design this next plant expansion? Or if you're a scientist, in this time of climate uncertainty, how do we monitor and measure the response of this ecosystem? Or if you're just a citizen, in this era of climate uncertainty, should I buy this SUV? Or how should I be managing the resources at my home more effectively in this era of climate uncertainty? Or most importantly, how do I teach my kids during this era? So I think if you could keep that perspective as we go through the program, I think that we need to put a lot of emphasis on thinking differently, and hopefully this program will help us do that. So a little bit about the Academy before we move into the program. The American Academy of Environmental Engineers and Scientists has as its main purpose the recognition of excellence in environmental engineering and science. And we do that in several ways. It's an atypical organization. Most professional organizations, you pay dues and you become a member. In the Academy's case, you have to qualify professionally and then you get to pay dues. So the board certification that's offered by the Academy is something similar to what you hear about for surgeons, for example, or dentists having a board certification. It's a level of recognition beyond the typical license that a person might have. So in our case, for engineers, it's a step beyond the PE license. And so being board certified Well, so what? What does that mean? What do you get? What's the benefit of being board certified? Each of you has a handout on your place like this, and it lists the benefits of becoming board certified. And I'm going to highlight just a few of those in this presentation. So when you become board certified, you've demonstrated to your peers and to your employers a commitment to excellence. In addition, the Academy has a robust awards program that presents national level awards to both individuals and to projects. If you're an employer, if you had board certified members on your staff, it's been shown that you have a competitive advantage in selection processes. And if you're a public agency, having board certified members on your staff gives the public an assurance of excellence in your work and decision makers also. So how do you join? Well, here's some information that you can jot down on how to become board certified, either as an environmental engineer or a scientist. And see me afterwards, or anyone who has this blue stripe on the bottom of their badge can help you get involved in the Academy. I think at this time, when good environmental engineering and science need to be the fundamental process, if you will, for decision making, the Academy's role in recognizing excellence is even more important. So as environmental engineers and scientists who become board certified, we can help guide decisions that are so important these days. So let me introduce our moderators and get into the program. We have two moderators, Wendy Wirt, who we've introduced already. Wendy is a board certified environmental engineer. She's also on the board of trustees of the Academy. So that's the national level governing board. She's been with Los Angeles County Sanitation Districts for 20 years. She prides herself in educating the public and decision makers on environmental matters, collection of wastewater treatment, recycling, stormwater management. She's played roles in design, facilities planning, and public information at the districts, and she devotes a tremendous amount of her own personal time outside of work to educating the public and to professional activities. She did her undergraduate and graduate work at the University of Central Florida. Professor Mike Stenstrom is also one of our moderators tonight. He's the Distinguished Professor of Civil and Environmental Engineering here at UCLA. He's a board certified, in addition to his academic credentials, he's a board certified environmental engineer and a professional engineer. His focus in research and instruction has been on biological treatment, on improved computing methods, and stormwater management. And he's the past department chair. He's been an assistant dean for computing resources and associate dean for research and facilities. He's developed the computing network that the entire engineering student body here at UCLA uses. His undergraduate and PhD are from Clemson. So it's my pleasure to introduce Mike and have him come up to the podium here and introduce the first speaker. And did you want to?
Well, thank you, Mike. I appreciate that. Sometimes I don't know what I've done, but I'm glad to hear every now and then something about what I've done. And it's great to see some familiar faces in the audience, former students who succeeded in spite of our best efforts to educate them. And welcome back to UCLA. This is an interesting part of the campus where we can have meetings, and you can see it's close to the dormitories where all the students are. So our first speaker is Mark Gold, Dr. Mark Gold, who really doesn't need an introduction. I'm sure you know of him. And there's a lot of things here about him, which I'll give him more time. But what I'd like to say is that he's one of our favorite alum. He's a graduate of our ES&E program, Doctor of Environmental Science and Engineering. And he was the first employee of Heal the Bay back when Dorothy Green was getting things going. And Heal the Bay was a really important organization, both before Mark joined and after Mark became the president of Heal the Bay. But it wasn't enough for him, and he came back for us, and he's now Associate Vice Chancellor at UCLA, working on sustainability and Grand Challenge programs. So Mark.
Thank you. Mike actually survived being on my doctoral committee about 1 million years ago as well, so we go pretty far back. Interesting on this talk in that I wasn't really sure, to put together a formal talk in 10, 15 minutes on this topic, and now that I see who's actually here, I'm really glad that I didn't. Because this is definitely your classic preaching to the choir on this particular topic, since I think I know about 3/4 of this room. So for me to sort of give an academic talk on, I think doesn't really make a world of sense. So I'll try to get going on some of the things that I have been working on, but really sort of close on the topic at hand, and the people after me are going to get into more details on some of the things that are going on with their particular agencies. So I came back to UCLA about 7 years ago, and pretty soon after I helped put together the Sustainable LA Grand Challenge. And going back to what Mike did on introductions, climate was really the driver of that Grand Challenge. We had a faculty member here, young faculty member, I think a lot of you guys know, Alex Hall in Atmospheric and Oceanic Sciences. He had done some downscale modeling on the city of LA area, actually LA County as a whole, and pretty scary stuff in the outcome. This was, front page news back in 2012. And we sort of looked at that situation and said, how are we going to thrive in a hotter Los Angeles? And that's what became the Grand Challenge that a few of us put together. Alex Hall was on that team, myself, Glenn McDonald, and Diana Huffaker from engineering were part of the team that put the original concept together. And the chancellor announced at the end of 2013. And the concept was, how do you get this university, one of the world's great research universities, to get out of their individual silos and work across disciplines and try to solve some of the world's great problems. And we thought, let's start in our own backyard in the Los Angeles region. And how do you make the megacity of Los Angeles with the 10 million people who live here truly sustainable? And with Alex's work being the catalyst behind that, and knowing that we're set to have 4 to 5 degree increase in temperature, pretty much embedded into the system at this point. By mid-century, that this was something that we wanted to take on. Also, doubling the increase in doubling the risk of wildfire, reduce snowpack in our local mountains, et cetera, et cetera. And so we put this together. There was 28 faculty across every discipline and on campus, put together a work plan, and we got some funding and started some research within these various different areas. Typical, once you get a whole bunch of faculty together, you can imagine everyone's got completely different viewpoints on how to move forward on any sort of issue. And there was no difference here. And so the Grand Challenge might have been, how do you have these people who've always worked in silos their whole career, work across disciplines and work together on something that's an applied problem rather than a basic research problem, which is what the university, of course, is well known for. And so we came up with those sorts of recommendations, but what were the big areas? Well, the one that matters the most to the people in this room isn't just, okay, let's go to 100% renewable energy, which sounded really audacious in 2012, and now it's the law in the state of California. So it's amazing how things can change politically over time, with SB 100 becoming law just in the last few months. But on the water side, the thing that's actually, I think, a lot more difficult is you look at the city of LA during the height of the drought, where 11–12% of the water was local water. And we had the audacious goal of what would it take to get to 100% local water, which is obviously related to this topic. We live in a Mediterranean climate, average of 15 inches a year, but we never have an average year, as we all know. We've had roughly 5.3 inches of rain, in the last 20 months here within the Los Angeles County region. So it's been incredibly dry. And then obviously, as you know, in 2017, we had a pretty wet period right in there. And 5 years before that was record drought. So that's the context of that. And so having a bunch of faculty members sort of look at these sorts of issues and what can we do to actually get there was one of the interesting things that we've been looking at. We did some related work for the City of LA, Bureau of Sanitation in particular, but also partnering with the City of LA, looking at the City of LA as an example, looking at a wide variety of different integrated water management issues and how could you move towards local water in a way that's going to get you to water quality standards attainment on receiving waters, and also enhance those beneficial uses of local water supply, as well as reduce peak flows for flood control benefits as well. And so we did a modeling project, UCLA with Colorado School of Mines, and a lot of work went into that and worked with the city hand in glove on that project. A lot of good information that I think helped inform their One Water plan that just came out last October 10th, I guess, technically. So that fed a great deal of that plan. And just from the standpoint of feasibility, without getting into too much detail, if you sort of round off for the City of LA as an example, 500,000 acre feet per year for demand, and look at the potential at the 4 wastewater treatment plants, look at the potential on stormwater, looking at all the groundwater basins and what the capacity is within each of those basins, and doing a better job on stormwater capture, et cetera, you can get pretty darn close. Between Hyperion and Tillman, Glendale, Terminal Island, you can get up to, in theory, 250,000 acre feet per year of water supply from those sources. On stormwater, Mark Hanna, I see here in the audience, we used a lot of his work that he did with, I think, Raphael as well, from LA Department of Water and Power. So that's what I'm saying. I'm talking about preaching to the choir. 150,000 plus acre feet potential for stormwater capture and augmentation of groundwater supply. If really focusing on the eastern San Fernando Valley and the LA Forebay as examples. If you add other potential places for water capture, that number can go up. It just gets a lot more expensive to do so, but the potential is definitely there, and we quantified that. And we also looked at, obviously, groundwater basins. We haven't gotten the most out of our groundwater basins, and it's great to see the City of LA moving in that direction. I'm sure you're going to hear more about that in a couple of minutes. But not waiting for Superfund to solve the problem, but actually take a pump and treat approach to providing local water supply and really increasing sustainable yields of our local groundwater basins are really critical to our future. And now it's at the point where the cost of pumping and treating local water supplies is competitive with imported water. And so that's something from the standpoint of looking at local water supply management is actually really critical and makes stormwater capture and infiltration even that much more important, not to mention increasing recycled water. We also looked at the issues of conservation and what we can do to get better on conservation. At the end of the day, we said, of course, as any academic would say, it's just a matter of money and resources, that you can get to 100% local water. And so that's something that could be done by 2050 if the resources were there to make it happen. The other benefits on that from a climate resilience perspective are pretty substantial. One of the things that Alex Hall has done subsequent to that work has been downscale model of the Sierras and what is happening there from the standpoint of what to expect on temperature, increase of average temperature of up to 10 degrees, and loss of snowpack from 4,000 to 7,000 feet on the Sierras. The scary part when you think about the questions that were posed is it shifts the hydrologic peak by 10 weeks earlier by end of century. And so from the standpoint of what are the impacts of that from the standpoint of our infrastructure and how do we manage that from a water supply perspective, from a flood control perspective, and then of course for those of you who care about salmon, what's the water temperature going to be end of summer early fall, et cetera, with the greatly reduced flows, higher temperature within those river systems. So those are the sorts of things to sort of think about. Whoops. Okay, missing your number. All right, got it. Those are some of the things to sort of think about from the standpoint of the scope and scale of the problem. And on the greenhouse gas emissions side, local water has less of a carbon footprint as well than importing water. So there's a lot of good reasons to look at local water. So in wrapping up, how are we going to get there from the standpoint of, right now we've taken this approach which has been largely reliant on water bonds and with pretty mixed success. We have another one before us in Proposition 3, which will be about $9.3 billion, if I recall correctly. We've already had $25 billion worth of water bonds to date. The LA region as a whole, Southern California, hasn't done as well as Northern California in utilization of those dollars. I think we've really got left at the altar quite a bit in getting our fair share, and that's something that needs to change dramatically, and people need to pull together to make sure that that happens in Sacramento. That has not happened enough, and I think that could lead to much more from the standpoint of local water supply. If we talk about things like regional reclaim, which you're going to hear about, LA County sanitation districts, the work they're doing, getting Hyperion to an advanced treatment plant, we're going to need that sort of water bond funding to help make that happen. Relying on the feds to help pay for things, I think, is really naive in this day and age. I think we've seen that over the last couple of decades, that it really needs to be taken care of at the state level. And then last and certainly not least is Measure W, which hopefully should be at the forefront of all of your minds right now on November 6th. That's $300 million a year, long overdue LA County-wide stormwater measure to finally parcel tax to bring money towards not only stormwater pollution abatement, but also an investment in local water supply. And so that in particular, I think, is the way for us to, one of the ways for us to move forward very quickly on local water supply, and we will know about that in just 3 short weeks. Thank you.
Thank you, Mark. So many of you may have come here tonight expecting Jeff Keitlinger, and I am pleased to let you know that we have Devon Upday instead. So he's filling in to talk about, and let me give you a little bit about Devon. Devon is the Assistant General Manager and Chief Operating Officer for Metropolitan. He's responsible for many of the operational business functions for the district, which include system operations, engineering, planning, and water resources management. In this position, one of his primary duties is to implement the Chief Executive Officer's business plan and initiatives, as well as to oversee the implementation and application of operational practices and the board's policies and directives. So with that, I'm going to bring Devon up here to tell us a little bit more about some of the partnerships that we have in this new era of recycled water.
Thank you. Good evening, everybody. And thank you very much for the introduction, and thanks for having me here tonight. So that's right, I work for the Metropolitan Water District, a major water importer and the largest water wholesaler to urban areas in the United States. So why am I on this panel tonight talking about local resilience? The reason is because I wanted to share with you some information about a major partnership that we've struck that represents a great opportunity for our region to help develop additional local supplies in the form of recycled water here. So I wanted to share with you a little bit information about that program. The partnership is with the LA County Sanitation Districts and Metropolitan Water District. And the idea behind this partnership is to create a program that would vastly increase the amount of recycled water that is made available to groundwater basins here within our service area. And I'm going to show you what that would look like a little bit later on, but that's the general concept. But first I wanted to start by talking a little bit about the need for this kind of investment and program with you. So what you see on this first graphic is a depiction of the amount of local water that is produced here within Southern California. This is not just the LA region. This is metropolitan service area, so we're talking about a 6-county service area from Ventura County down through LA, Orange, parts of Riverside and San Bernardino County, and then San Diego down to the border with Mexico. So it's a pretty large area. And the first piece that you see on this graphic is production of groundwater, which is the largest piece of the local pie in Southern California. The little sliver that you see on top of that is contaminated groundwater that's been treated. So in total, that's groundwater production in 2 different pieces. And you can see over this short period of time, so this is from 2007 through 2017, flat to declining groundwater production in this region. What this shows you is groundwater storage levels. And it's kind of the inverse of what you typically expect to see. As the bars get longer, that means that groundwater levels in storage have actually dropped. So you're seeing, as we go through time here, storage levels across all of the groundwater basins. This is a little bit more than 80 different basins here in Southern California. Typically, through this period, they're dropping a little bit. You see some rebounds when you see wet cycles, but here the estimate for 2018, while it ticked up a little bit in 2017, that here in 2018 you'll see it drop a little bit more. And that line that you see across this graphic is the amalgamation of what's deemed to be the healthy levels across all of those basins. If you add all of that up, the healthy level is significantly above where we actually are today. So across most of these basins, some are different than others, but across them in total, you're seeing levels that have dropped below what the basin managers would consider to be typically healthy levels. So now we go back to this graphic to give you a sense of the other local supplies that come into the service area. And the surface water, the darker orange color there, it's water that's captured and is used for direct use. A little bit of treatment may be added. Then on top of that, the lighter orange or yellow color is the Los Angeles Aqueduct. Some people might not classify that as a local supply. We include that in our local supply graphics because it's not a supply that has to come from us for Metropolitan. And you can see pretty significant fluctuations in that piece of the pie. In fact, in 2017, you'll notice that number is a lot higher, and you might remember 2017 was a wetter year up north, and so that's why there was more Los Angeles Aqueduct supply coming down into the region. And then on top of that, you see purple, you see recycled water of all different forms. So this is capturing many different types of recycled water that are going to meet a need here in Southern California. And then a very small sliver in the last couple years up at the very top that is seawater desalination, which is representative of the facility down in the Carlsbad area that came online. That kind of rounds out the general picture of the major local supplies that you see here year by year. Average production over this period of a little bit less than 2 million acre feet a year. Now, when we look at our long-range plans and we set targets as Metropolitan, we set targets for the region where if you meet those targets, the region would be very reliable into the future. Our plan for 2040 shows a target on this screen where those orange dotted lines are on the right side. 2.4 million acre feet, just a little bit higher than 2.4 million acre feet of locally generated supply here within the region. That's the goal. And what you can see is more than 450,000 acre foot difference between where we want to be in 2040 and what the production level, kind of average level, has been over the last approximately 10 years. So that's a pretty significant gap, and you can see that starts to paint the reason why you need to be making the kinds of investments that the panel will be talking about and the one that I'll be talking about here in this presentation. So that's why pursue local recycled water. I think that makes the case right there. So let's talk a little bit about this partnership. When you look at this partnership, it's 2 major regional agencies. On the right side, you see the sanitation districts of Los Angeles County with some general goals that they've got in terms of increasing the overall reuse within their system and starting the reuse process at their joint water pollution control facility down in the city of Carson and reducing ocean discharges. With us as a major water provider in the service area, we want to diversify our regional supplies. The idea being that you take a mutual fund approach to investing in supply reliability, it's going to make you more reliable in the future. Improving storage and delivery capabilities in the region, I showed you the graphics that show what's happening with groundwater storage and groundwater levels overall. There are some basins that have taken significant haircuts in the amount of water that they're able to produce because the basin levels have dropped. So we want to be able to help with those local situations. And then ultimately, improve drought resistance, and we believe that recycled water is a drought-proof supply to some degree and something that would help with meeting our long-term reliability goals. So this is kind of a graphical way of showing what these facilities might look like. The idea is, if you're familiar with where the LA Galaxy play, the soccer team, a facility that would be jointly located with the Joint Water Pollution Control Plant just a few miles away from the Galaxy Stadium. And then a series of distribution lines and facilities that would take water out to groundwater basins and a few points of industrial demands that would be met by the highly treated water coming from this facility. And you can see some of the different basins on this graphic that would benefit from this conceptual program at this point. But where are we with the current program activities, moving from that concept to trying to make that a reality? This is an aerial view of that Joint Water Pollution Control Facility. In blue, you see space that's available there that could be used for the long-term program. What I'd focus for you is the little yellow piece there, which is the location for where we're actually building in this partnership a demonstration facility to prove out the treatment technology and the concept for the full-scale facility. That demonstration facility, this slide shows 65% complete. It's actually about 80% complete as of our speaking tonight. The idea is for that facility to be complete roughly around the beginning of the year. We'll go through the testing and startup process, and we'd probably be having a ribbon cutting for the operation of that facility in the March 2019 timeframe. So this is becoming a reality in terms of making this demo facility the real deal. And this gives you just the cartoon graphic that our engineering folks put together. You can see the different processes that are involved here, but capture the picture of that cartoonish graphic in your mind, and this is where we are with the actual construction right now. So it looks a lot like the original concept piece. And we're making great headway in bringing this to fruition. So some key objectives. This facility is going to help us move through the regulatory acceptance process. We've already engaged the regulators as the facility is being built, as we've brought together an independent panel to work with the regulators and help move through that process. It's going to help us optimize the ultimate treatment design for the full-scale facility, and it's going to give us a better sense of what the long-term costs of the full-scale program will look like. We're also going to be putting next to the facility an outreach facility there that will work for us being able to bring people through to take a look at the way the demonstration facility works and gain public acceptance to a greater degree. So the current activities that we have are not just related to that demonstration facility. We are going to be releasing a conceptual planning and phasing analysis early in 2019. The idea is we've done feasibility work. We know that it's possible to do this program. We've got general costs, roughly $2.7 billion for the ultimate program that would be producing up to 168,000 acre-feet a year of new water supply that could be used. But how do you phase that? What do the alignments look like? Is there a staging process for this facility? Do you build it all at once, or do you build it in pieces over time? So we're going to be releasing a study that takes a look at that in early 2019. The other thing that I would really focus on with you here as part of this process, it's a great opportunity for us, but there are a lot of things for us to talk about and consider as Metropolitan, as an agency. If you take a look at our history, I started off with this. We are an imported water supplier. We were brought into being originally to build the Colorado River Aqueduct to bring imported water supplies into the region. And that was what we were supposed to do. If you take a look at our policy history, in the 1950s, our board took an action to change our role and our mission within the region, to become an agency that was planning on how to be reliable, how to make sure that the region was reliable. That led to investments in the State Water Project. That also led to us starting to look at how we could help local agencies develop local supplies, and it also led to the proposal, advancement, and implementation of a conservation program that serves all of Southern California. Major marquee events. But the way that we've helped with local supply development up to this point has been through investing and incentivizing local agencies to develop those supplies. What that means is that water never enters our system. It's never distributed through our lines. We don't own and operate those facilities. That is a very big difference between what we've done in the past and what's being considered today through this regional recycled water program. For us, the scale of the benefits warrant us taking a look at this, doing the demonstration facility, and talking with our board and our members about whether this opportunity can be brought by us and done by us. The costs are higher than imported supplies. So I said that $2.7 billion figure, that estimate. To give you a sense, that translates to about $1,600 an acre foot. Right now, imported water supplies are about $1,000 an acre foot. So there's a differential there. So it causes us to ask questions about how would we fund that? How would we move that into our rates, and how would our agencies pay for that? Great opportunity, but we have to work through those kinds of discussions before we're able to take that next step and actually implement the full program. So I just wanted to share that with you in terms of it's a great chance for us to have additional beneficial impacts on the region, but we have some significant things that we have to work through as an agency. Our board has also asked us about what if the state board and the state in general were to grow more comfortable with direct potable reuse as an option. Is there a way that that could come into play for this kind of project? And this is a graphic that I wanted to show you. This shows less cartoonish and more of an alignment-based approach for the way you would actually distribute the water to the different spots, the different basins. And the orange line in the upper right portion of this actually shows how we could have a line that, if the permitting path were there, you could bring this water all the way to the headworks of the very first treatment facility, the very first filtration plant that we built in the Weymouth treatment plant, which is up in the city of Laverne. If we were able to get the water to that facility, you would then be able to move that water through our regional distribution infrastructure throughout Los Angeles, parts of Orange County, to a base of millions of people. So not just to the groundwater basins, but that would be an option that would allow you to conceptualize direct potable reuse in the way that it could interact with this facility in the future. I think that that's still far off in terms of permitting path and capabilities, but there is an option for this facility down the road if that possibility occurs. So to give you a sense of schedule, what you see on the top line here is the work on the demonstration facility. That being roughly complete around the beginning of 2019, starting operation later in 2019. The conceptual planning studies report I mentioned will be released in the early part of 2019. A lot of the institutional discussion with our board you will see on the very last line. We're going to have a series of workshops that are starting in the late spring, moving through summer of 2019, with the idea being, if we can get to a comfort level around moving forward with the next step, it would lead to us kicking off the environmental process in the fall of 2019. So that gives you a sense of the scope and the next steps that we have with this great opportunity before us. I'd be happy to answer questions a little bit later. Thank you.
Thank you very much for that interesting talk. Those of us that have been doing water reclamation for some time have been looking forward to rules for some direct potable reclamation, and I think we're going to see them soon. We have a number of projects where they lean towards that in the future. Our next speaker is Mr. Dan Lafferty. He is the acting deputy director of the Los Angeles County Department of Public Works, heading their environmental programs division. That division is responsible for the treatment of waste and water and waste for about 1.1 million people in the unincorporated area of Los Angeles. So if you're not part of LA-SAN or LACSD, you might be part of his organization. It includes 77 cities and 37 contract cities. So Dan began working for the department in 1986. His current assignment is in the Environmental Programs Division, but he's worked in water resources, watershed management, waterworks, and sewer maintenance. And he's a registered professional engineer in the state of California and a member of the California Bar. And when I looked at that, I thought, that seems mutually exclusive to me, but we'll hear from him.
All right, thank you very much. So the bio is just a little bit dated by just a couple of months. In August, I got moved over to our Water Resources Core Service area. So I left the Environmental Programs Division, and now I head up what basically is oversight of the Flood Control District, as well as the Waterworks districts that serve unincorporated county areas. And it's in that capacity that I'm going to talk to you tonight in terms of Measure W, and that is the Safe Clean Water Parcel Tax that is going to be on the ballot in just a couple of weeks, November 6th, that you'll all get a chance to weigh in on. So I'll kind of walk through the first couple of slides, kind of setting the stage, and then I'll dive into kind of the composition of that measure and the way that those funds would then be distributed and utilized. So this represents kind of the broad general water portfolio for the region. And as you can see, we've got a significant portion there that is imported water supplies. So one of the challenges that we face, and we've been talking about it already for quite a bit tonight, is resiliency within the region. And there is, the reliability factor, but then also the ability to withstand events that may not be well anticipated. And so when you have such a significant portion of your water coming from outside your region, you are at risk then of disruption and the difficulties that would pose for all of us. So I had a boss one time that early on in my career talked about, the wet-dry cycles. And, we've got the wet season and the dry season, but we also have, decadal-long wet and dry cycles. And as we're talking about drought, are we out of a drought? And his response, asking him, his response to me was, look, if you rely on imported supplies for 2/3 of your water, you're in a constant state of drought. And that has stuck with me all through these years, that we take for granted that you turn the tap and the water comes on, but really, when you are looking to outside your region for that much of your water, you're kind of putting yourself at a significant risk. And so that was one of the drivers for the development of this measure, is how do we improve the resiliency of the region when it comes to our water supplies? The other issue that we have is we've got a significant amount of pollution that enters into our streams and eventually out into the ocean, the bay and the ocean. And the flood control district system was built decades ago, the 40s and the 50s for the most part. And the request of the flood control district at that time was move this nuisance water out to the ocean as quick as you can and give us the maximum amount of developable space that we can have. And that's exactly the system that we have today. Societal values have changed significantly, I think for the better, since then. And now we recognize that we gave up an awful lot in terms of other values when we made those choices. And in those choices, we've created the problem of the urban areas contributing the pollution that we have into those waterways. So how do we now, given the system that's in place, how do we address that? Some of the other issues that we are confronted with is when you talk about water in Southern California and Los Angeles County in particular, there are a number of agencies who all have a role, and there is no unifying entity over the entire picture. And that makes it very difficult to have a region-wide approach to water as a resource. And so the idea is that maybe we can come up with a mechanism that kind of pulls all that together. So that really was the program approach. The kind of the first priority was, okay, we know we have this system that is creating difficulties for us when it comes to pollution, that is contributing to our waterways not meeting standards that we would like to see. We want to make sure that we are increasing local water supply to enhance the resiliency of those systems, to make sure that we can have water supplies, both those that are less susceptible to interruption, but also from an environmental perspective are just a better approach, as Dr. Gold was talking about, in terms of your carbon footprint and many other issues that arise through using imported supplies. And then finally, when this money comes in, can we figure out ways that in achieving objectives 1 and 2 also provide some enhancements to the communities? Are there ways that this money can the projects that we could fund with these could also be of benefit to the communities themselves? So we realize this is a regional issue. This is not limited to unincorporated county areas. It's not limited to one city. And when you have a regional issue, clearly the best approach is a regional approach. And it's for that reason that the county and the Board of Supervisors in particular tasked the Department of Public Works with developing a plan to address all these different elements. And that then became the Safe Clean Water Program. The program element that is of greatest concern is the parcel tax. It would be a tax of 2.5 cents per square foot for impermeable area. That would generate about $300 million annually in revenues. And that money then would go towards projects that are watershed-based. And there's an approach where we recognize that there are regional projects that need to take place, but there are also very localized projects that need to take place that can assist us in creating regional resilience. It may be an individualized local project, but cumulatively, when you start talking about all those local projects, they actually do have a regional benefit. So the program is set up where the pie that gets collected gets split into 3 pieces. 50% of the total revenues that would get collected would go towards these large regional programs. The idea is that those monies would actually be returned or spent within the watershed areas, and there are 9 of them in this program. And the amount of money that gets collected in each of those watershed areas, they would get, the money that would get spent would be proportionate to the revenues that they generate. So it would kind of be a return back to the same communities that provided the money to begin with. The essence in these projects, again, is water quality and then water supply, but also making sure that these regional projects have a benefit in terms of multi-benefit, not just those 2, but can we get recreational benefits, can we get habitat benefits, and additional benefits beyond just water quality and water supply. This is the governance structure that we would propose that's going to be in place should the measure pass. And as you can see, there's a great many layers that are involved here. And the idea is to make sure that the money is being spent the right way on the right things. So you do have the project applicants. Within each of these watersheds, there would be a steering committee that reviews those projects and determines from the watershed basis which ones are the priorities. There then is a regional oversight committee whose real job is to make sure that the program elements and the purposes for which the money was being collected are actually being spent the right way. Finally, there is the Board of Supervisors. Since these are regional programs and it is the tax being collected by the county, they would basically affirm that these are the right projects to move forward with. And you can take a look here in terms of where that revenue comes from. And so those, again, those watersheds would see a return based on the amount of revenue that we would expect to receive from them. There then is the municipal program. This is 40%, and this is a direct return. It's a direct return to the cities, and it is, again, proportionate. The revenue that gets collected from them, that 40% gets split up and returned to those cities. There's a little more flexibility in terms of how that money gets spent. There must be a water quality element to the project that the cities would use these funds for. It then also allows for these funds to be spent on maintenance of these stormwater quality facilities. So there's a little more flexibility to these cities to make the choices that they think are best. And you can take a look at some of the larger areas and the expected return to those cities out of that $300 million. Finally, there's the remaining 10%. And this is going to come to the flood control district. You can see the different elements that would the monies that collected would be used for. There's obviously some administration. One of the things too that the flood control district is willing to do, if asked, is provide technical assistance to the municipalities or other agencies or entities that are interested in participating in the program. There's a proportion that's set aside for educational programs. That can be no more than 5% of that 10% that we can put out educational pieces to the community at large. And again, regional studies and workforce training. So that's where that 10% is going to be going. So when we talk about impermeable area, what are we speaking about? If you think about constructed surfaces, that's really what we're talking about. Yes, your pool counts. That too is impermeable. So at 2.5 cents per impermeable foot, if you looked at your property, that's where that's going to get calculated. Now the mechanism for that, there's several data sources, multiband aerial imagery, 3D mapping or LiDAR, and aerial photos. And so this all gets combined parcel by parcel to determine what that tax would be. There was an independent analysis done by the University of Vermont. I'm not exactly sure why we picked the University of Vermont or why they were an interest. I don't know. But they determined that through this process, there's a 98% level of accuracy in terms of the results. Although for those times when there is an inaccuracy, there is a appeals process. If you feel that you've been inappropriately assessed, there is a process to challenge that. There are also exemptions and credits within the program. You can see here the list of parcels that would not be taxed. The Antelope Valley is on there for the simple reason that it is outside the flood control district. So the parcel tax is for all parcels that are within district boundaries, and the district goes up to Avenue S up in the Antelope Valley. The credit system is really about those folks who have been proactive, and they have taken measures to manage their portion of storm flows without having taken advantage of these types of programs. So there's a recognition that people have been working and that there are property owners out there that have done good work in terms of trying to retain flows on their properties. So this is a way to recognize that if you are not contributing as much to the runoff, then clearly you shouldn't be paying as much in terms of this particular parcel tax. The likelihood is that the difference to get from 80 to 100%, there's a significant level of effort. The reality is to get to the 100%, you've got to be thinking more than just your own property. And if it's all contained within yours, you can probably get up to 80. But to move up to that 100%, you're doing a little more than just your own property. And these are the types of projects that we kind of foresee as being kind of the ones that would get funded. So we'll kind of take a quick walk through those. Dominguez Gap Wetlands, I'm not sure if anybody's been down to that part of the county. That was an old flood control district piece of property. It was a spreading grounds that historically had not done such a great job of recharge, but it was perfectly situated and suited to create constructed wetlands. Then we've got Green Streets, Elmer Avenue. I'm sure you've seen some of these as you're driving around, where we're diverting flows off the street into bioswales and then allowing those flows to infiltrate. One of the bigger projects that we're in the midst of is a project at Bassett High School, where we are peeling back the fields, the athletic fields at the high school, putting in underground infiltration galleries, and then putting those fields back into place I kind of see that as sort of the leading projects. When you start thinking about where do we still have open space, it really is about parks, and it's about high school ball fields at this point. So this is the ballot question that you're all going to see. And I can tell you, when you talk about wordsmithing, this went through some very diligent wordsmithing. And this is the question that you're all going to be asked to weigh in on November 6th. Hopefully, the folks in LA County agree that the time has come and that we do need the funding to really take care of what has been a fiscal orphan in terms of stormwater quality in particular. But we'll find out come November 6th.
Thank you, Dan. I just want to cue up the... I trust Tracy, right? Our next speaker is Tracy Minima. She's the Chief Operating Officer with the City of Los Angeles. City of Los Angeles has approximately 3,000 employees with an annual revenue of nearly $1 billion. Tracy holds a Bachelor of Science degree in Civil Engineering from Cal Poly Pomona. She's very educated, a Master of Science degree in Environmental Engineering from Loyola Marymount University, certification in Executive Management from Harvard. She's also a licensed professional engineer with the state of California and a board-certified environmental engineer. Tracy currently serves as a board director for the California Association of Sanitation Agencies, and she's a member of the State Water Resources Control Board Advisory Panel for direct potable reuse. Tracy was my first client after graduate school, so you students that are out there, you can see that these relationships last for your entire career. So welcome, Tracy.
Okay, good evening, everyone. Thank you so much to AAEES for inviting me here today, and Mark also for getting me up here. I'm happy to be here. I was asked to talk a little bit about the City of Los Angeles Sustainability Plan, and in particular, the area of water resources. So I'm going to start off kind of setting the foundation here. Our Mayor Garcetti is a very environmental person. His agenda includes a lot of items in respect to how do we protect the environment, how do we make sure that we're doing our part in the city of Los Angeles. And when it comes to water, in particular, during the drought that we've all been talking about, during the height of that drought back in 2014, Mayor Garcetti issued Executive Directive Number 5, creating a water-wise city. And in that directive, there were goals established for water conservation, as well as how we can increase our local water supplies. He followed that with Executive Directive Number 7, including a sustainable city plan. And this plan is kind of the major foundation which sanitation and environment was able to shoot from to start working on some of the goals and targets that he had established. Basically under 3 themes: environment, economy, and equity. Of course, we were focusing in the environmental arena. So under that sustainable city plan, there were 3 pillars that we focused on in regard to water. One is recycled water, stormwater, and then groundwater. In recycled water, 2 of the most significant goals that were established were to reduce the purchase of imported water by 50% by 2025, and to source 50% of our water locally by 2035. In the area of stormwater, we talked about increasing or improving our water quality in the beach areas, in basically all the runoff that we see through our stormwater system. We also talk about supply in our stormwater arena and want to increase that capture to 150,000 acre-feet per year by 2035. In the area of groundwater, we talk about cleaning up our San Fernando groundwater basin and securing additional funding for that cleanup. Susan's going to be spending more time talking about groundwater. I'm going to focus on recycled water and stormwater. So this is our baseline. In 2015, we established starting point there of 550,000 acre feet per year as our production, equivalent to that 490 million gallons a day. And what you see here is that the two blue segments, the Los Angeles Aqueduct at 29% and the MWD at 57%, totaled 86% of imported water. The other portions you'll see are groundwater at 12% and recycled water at 2%. So that's what's considered our local supply. So you total up imported water at 86%. The goal is to say that local water needs to consist of 50%. You do all of the math, and that means we need an additional 135,000 acre feet per year of local supplies. So how do we create more local water? I just want to spend a few minutes talking about our wastewater system and about all of the recycled water efforts that are taking place at each of our 4 water reclamation plants. And I'll start with Terminal Island. Terminal Island is down in the San Pedro, Wilmington area. It's its separate standalone system there. We have, in 2016, completed the expansion of our existing advanced water purification facility by doubling its capacity to 12 million gallons a day. This treatment plant now brings in all of the raw sewage from the Wilmington-San Pedro area. We treat it through tertiary filtration, and we follow that by microfiltration, reverse osmosis, and an advanced oxidation process. That water is used, is an indirect potable reuse project to inject into the Dominguez Gap barrier as a seawater intrusion mechanism. We're also using a portion of that water, or will be soon, delivering a portion of that water to some of the refineries in the area. At Los Angeles Glendale Water Reclamation Plant, this is the plant across from Griffith Park. It's in our Hyperion service area. Both Glendale and Tillman are within our Hyperion service area, and the water reclamation plants that exist there treat the water, discharge solids back to the sewer system, which are then handled at Hyperion. The water that we treat at Tillman and Glendale is to tertiary standards, and a portion of that is used for industrial use as well as landscape. And then the rest of that is discharged to the LA River for environmental habitat creation and recreational uses. So what we wanted to do at LA Glendale was increase the amount of water that we can actually get through the treatment plant. And we're doing this by implementing a project with flow equalization. So basically what we're doing is adding 2.5 million gallons of equalization for our primary effluent, as well as a few additional primary tanks, aeration tanks, and secondary clarifiers. So by adding this flow equalization, we'll be able to increase the average output at LAG by roughly 4 million gallons a day. And what that allows us to do is, both through the City of Los Angeles and the City of Glendale, expand our recycled water programs to use some of that for recycled water, and at the same time continue to support the LA River with the water that we currently send there. Another added benefit of this project is that it will provide us with wet weather relief. We have some choke points in that area in our sewer collection system. So by allowing us to capture some of that flow through equalization during the high peak storms, then we are able to improve our assurance of keeping all of the wastewater in the sewer. Tillman Water Reclamation Plant is out in the San Fernando Valley. We're very excited about a new project that's been in the works for quite some time now. And we're just finishing. We finished the pilot phase of the work that we were doing there, and we are currently out with a request for proposal to hire a design build team to help us with this construction. What it consists of is 25 million gallons of advanced treatment. This water will be used as an indirect potable recharge project to add water to the San Fernando groundwater basin through the Hansen spreading grounds. We completed the pilot testing This is on an ozone BAC treatment technology. So it's an alternative to the traditional microfiltration reverse osmosis treatment. And I have a slide to show you a little bit about the process treatment train for that. We are also working on an ozone demonstration facility. This is kind of an interim project. It's going to take us a good 5 years to actually have the full advanced treatment project up and running. So in the interim, we're doing an ozone demonstration facility, and what that will do is take the tertiary treated water, ozonate it, and give us a better quality water that we will then be able to spread at Hansen spreading grounds. That will be 7 million gallons a day, and it's scheduled to be online in the spring of next year. Another interesting component that has become a part of this advanced water treatment project is a redirection of some of our sewage. As a result of all the water conservation and the success that we've had in that arena, what we've seen is a decline in the amount of wastewater that's discharged to the sewers. So when we originally envisioned this project and were scoping it out back in 2012, we had plenty of water. Now we don't have as much water. So what we're needing to do is redirect some of the flow that currently now goes down to Hyperion and send it over to Tillman. And that's what we're calling our East-West Valley Interceptor Sewer. So that'll give us another 9 to 10 MGD that will allow us to maintain our original plan of 25 MGD of product water. We are on schedule to make this thing operational by 2023. So here's our process treatment train, and this is why we spent 2 years on pilot work and doing the research at Tillman, because we were trying to look for a newer process that has benefits to the traditional MFRO treatment. So what we're talking about is taking the tertiary filtered water through our standard process, ozonating it, sending it through biological activated carbon as a filter, again through granular activated carbon as another filter, and then UV. After the ultraviolet treatment, we'd be sending it over to the Hansen spreading grounds, and it would get the additional soil aquifer treatment by going through the groundwater aquifer in its natural process. By doing something like this, what we're really going to be able to see are benefits such as, one, we won't be producing brine. Big benefit, because what happens if we do produce brine is it goes down to Hyperion, and we want to recycle at Hyperion as well. So that's a big benefit. Another is that it's much less energy intensive, so we are reducing our carbon footprint. It's much more environmentally friendly from that perspective. Another is that the capital cost is significantly less. You also see that we have a side stream there of fat, the full advanced treatment with the MF and RO. We're working with the Division of Drinking Water right now at the state to see what we can actually get permitted. Our hope is that all of the flow can go through this alternative advanced treatment train without having to do the MFRO. But if we need to supplement with a side stream, we also have that in the plans as a possibility. So at Hyperion, currently we recycle about 70 million gallons a day of the water at that plant. We receive about 240 million gallons a day. A lot of this water is reused internally as well as sent to West Basin Municipal Water District. We're working on a 1.5 MGD advanced water purification facility. This facility is going to be supplying water to LAX Airport. The uses are not such that the water actually needs to be advanced treated, but it's important for us to provide this high quality water. As you would all agree, LAX is a very high profile location to be using recycled water. We want to make sure that it's the best quality water possible. So that's scheduled to be online in 2021. We're currently going through the selection process for a progressive design build delivery method. We are also working on an MBR pilot. This is very similar to what Devon was talking about on the LA County sanitation demonstration. We're going to be doing some pilot work to test out how membrane biological reactors work with the wastewater that we receive at Hyperion. that will really give us an idea of what kind of conditioning, if you will, we can do on our standard treatment process as it feeds into an advanced water treatment. Full expansion is out there. Mark talked a lot about everything that we're doing at the treatment plants and about the need to really capitalize on Hyperion as a major resource. So we have more than 100 million gallons a day that we're working on. We're working on a couple of studies right now with the Department of Water and Power. One as to if we were to produce this water, and when we do produce this advanced treated recyclable water, how would we distribute it? Where would it go? It's a lot of water. So that's one effort that's underway right now. We're also looking at the footprint of Hyperion itself. It's 144 acres, about the size of Disneyland. A lot of operations already going on there, and we're taking a look at how we would actually fit the footprint of advanced treatment on the site itself. Okay, so shifting over to stormwater. Dan talked a lot about stormwater and the benefits for increasing our water supply, and also the point about how we need to work on our water quality first. Some of the studies that UCLA had assisted us on were on the Upper LA River, Ballona Creek, and Santa Monica Bay. These are some of our three largest watersheds within the city of Los Angeles, and that's where we need to focus in terms of what we need to do to improve the water quality of all that stormwater runoff. We are regulated through our MS4 permit, which is our stormwater permit, and we are required to comply with total maximum daily load regulations. What we're seeing with the projects that we've put on the board are that we can improve the water quality of up to 90,000 acre-feet per year, which could then be used as water to support groundwater infiltration and other needs. These are some of the ideas of projects that can be managed, starting first with rainwater capture on private parcels, so things like rain barrels, grassy swales, bioswales, ways to capture the water on private parcels, primarily residential, smaller scale, but they do make a difference. Next, green streets and other distributed projects. So these are projects that would occur along the streets with curb cutouts, for example, to capture some of that water and divert it into the greenways to support landscape along the area. And then finally, the regional projects. Those are the big projects that include detention basins, large areas, projects that would include multiple partners as well as multiple funding sources. So when you look at our 5 watersheds, we kind of took a look at, okay, in order for us to be in compliance with our water quality requirements, those are the total maximum daily loads and our stormwater permit requirements, this is the investment that we need to make. So for the city of LA alone, we're looking at $7.3 billion. You can see the distribution here also on the 90,000 acre-feet per year. That would be the additional supply that we could get from treating all of this stormwater runoff. So overall benefits and challenges. One, of course, we've talked about this amongst all of us speaking today, and that is on local resource reliability. We're going to improve our resilience and our sustainability. We're going to improve and enhance the community overall. Multi-benefit projects are going to be ways that we leverage the resources, partnering with other agencies in order to get the biggest bang for the buck. Some of the challenges that we see, of course, is funding. That's always an issue. One is schedules also. With our permits, we have deadlines. We are required to be in compliance with these regulations by certain end dates. And finding the mechanisms to get the funding to support the development of those projects and being on schedule is something that we are constantly trying to meet. Implementing emerging technologies, that's also a challenge. I think as engineers, we all know that it takes time to design and to build a project. So when there are technologies out there, you want to try to manage your risk in terms of something new and something emerging, and deciding to do that without really yet knowing if it's established and it's going to work for you, and comparing that against technologies that are established and well-known. At the same time, once your project's online, you don't want to be sitting there with technology that's now been replaced by something better. So we're constantly trying to keep up and to balance those competing factors as well. Development of water recycling regulations, it's funny, you know, it's like, when do you really want to have more regulations placed upon yourself with more requirements to meet? But really what we're talking about is uniform water recycling criteria. It's not all out there yet. Some of it is there for IPR. We're moving more towards DPR and direct potable reuse. And by having those uniform water quality criteria, we'll be able to understand where it is we need to be and what kind of treatment we need to have in place in order to meet those requirements. So that would be very helpful for us, and we continue to work with the regional board and the state board in that regard. Public outreach and acceptance is also a challenge. I think we've made a lot of progress over the last years. With the drought that we just got through, I think there's a lot more awareness now of the scarcity of water and the value of water. So we've seen a big turnaround in terms of public acceptance of these projects that we're talking about. So that's a very positive sign. So basically, just to wrap it up, our sustainability plan provides us with a basic foundation. It identifies targets, it has specific actionable items, and it requires each of our departments to provide annual updates to our mayor and report on the outcomes. So really our feet are being held to the fire, and we're excited and up for that challenge. We're moving forward on multiple fronts to secure our local water resources. As I mentioned and talked about here, the recycled water is going on at all of our water reclamation plants. We have projects to increase our amount of production. Stormwater quality coupled with increased groundwater supply is also a very big component of our program, and groundwater cleanup is also an important factor. So thank you, and I'll be ready to answer questions at the end of the discussion.
Thank you very much. I guess we're all going to be drinking reclaimed water pretty soon. So our next speaker is Susan Rogani. She is the Director of Water Engineering and Technical Services at LADWP. And it's interesting to note that it's the largest municipal water and power utility in the nation. Municipal. And serves over 5 million people. And I hear from them every other month with this fat bill I get. So let's hear about that.
So just to say that fat bill is for water, power, and city services. So it's not all water. So just to clarify, just to let you know, I have some issues with my voice, so please bear with me as I go through the presentation, especially if I talk too long. So okay, so that's probably a signal. Okay, so thank you very much. I'm happy to be here, and some of the things that were already discussed, I'll probably go through them, especially with Tracy and sanitation, because actually for us it's a true partnership, because LA Sanitation actually treats the recycled water that then DWP then takes and conveys to our various customers. So it has to be a true partnership. She talked about some of the studies we're doing together, but in order to make this work, we work closely together. Also, when we talked about the regional aspects of recycled water, reclaimed water, of course, from MET, those are all things that we're aware of and trying to work very closely because we're not just focused on the city part of it, but it's pretty much the broader picture of what we have to look at when we look at sustainable supply actually for this region. So I'll start. Let's see. Okay, so this is just, of course, water supply. It's just to illustrate the point, which I think most of you are pretty familiar with, that pretty much all of our water is imported. So when the mayor says, okay, have to rely on sources of supply of closer to home, that's that little blue part that says local groundwater and stormwater. and it also says conservation and recycled water. So that's pretty much what we have to work with. Of course, especially in times of drought, the other sources of supply are very important to us. We have got as much as, of course, in times of drought, 50% from imported supply. But of course, we're trying to move to reliance more on local supplies, which you see, of course, in the box in the bottom. Okay, so when I said local water supply strategies, pretty much it's these 4 pillars that you see. So water conservation, of course, is not a source of supply, so to speak, but it has to do with the demand side management. So it's kind of like, okay, how do we kind of reduce the demand on the supplies that we have? So it's water conservation, of course, recycled water, which Tracy talked about. We talked about stormwater capture, and of course, groundwater replenishment and basin remediation. So that's the 4 pillars, I guess, of the chair you'd say we're sitting upon when we look for local water supply strategies. Okay, this kind of takes you back to where we were in the past, where we are today, and of course, we hope it doesn't show what the future could bring, but of course, the future, hopefully, we see some of these numbers decreasing. So if you look back 50 years ago in 1970, we're pretty much using almost more water than we are today, with additional 1 million people more. So that's quite a bit of people more. Of course, there's this little box that says 106 gallons per person a day. That was quite the achievement, because that our mayor put the options out in front of us. You have to cut back 20% as far as your demands, and that's something that we achieved the mayor's goal. So it's I think we're pretty proud of that as a city, because we reduced our demand very much. Okay, so looking at these 2 circles here, pie charts. Okay, one, of course, is current. Where are we for the past 5 years? So you could see, of course, that we still rely quite a bit on the imported sources of supply. Okay, so you have Met, you have our aqueduct, and of course, that local supply is local groundwater and recycled water. If you look at future water sources, and we're looking out to 2040, and it's like, why are we looking to 2040? It's pretty much because that's what our urban water management plan, actually that's the time frame that we used to look at when we're projecting forward as far as our water sources. So what this tells you, you see more colors, which means, okay, we have a lot more variability and different sources of supply. So of course, I talked about conservation. You can see actually conservation, we anticipate hopefully that should cut, of course, the demand side about 16%. We also have recycled water that's increased 7%, local groundwater increased. Of course, the imports from the aqueduct and Met have, okay, closer to 50%. So that's just the overall picture. Okay, I talked about the urban water management plan, and that's pretty much the master plan for supply for the city of Los Angeles. That's something that's required every 5 years. We just finished the last one in 2015. And so you could see we take all this. We also have done, Tracy mentioned the sustainability plan for Los Angeles, stormwater capture master plan, which we finished in 2015, water conservation potential studies. So there's a lot of things that go into this urban water management plan. When we do the next one in 2020, you're going to see, okay, I showed you that chart in that shows projections for 2040. That's going to be tweaked a little bit, but I assume you're still going to see that array of colors and different sources of supply as we go forward. Okay, so I talked about water conservation, and this is the stuff that we've been doing since probably the 70s, since we had our first drought in Los Angeles. So, of course, we continue with outreach, education. We had a number of rebates and incentives, and of course, we still have the water efficiency ordinances. And for those of you who are not sure, we're still under the ordinance. So phase 2 of 7 steps of the ordinance for water conservation. So that still limits us to watering for three days a week. So that's something although we're not talking about a drought, we still have this water conservation ordinance that we are complying with. Okay, water conservation potential study. This is a study that was done actually last year and was kind of to say, okay, what are the other areas of conservation that we could look at and see, okay, can we hit? So we looked at what's the maximum potential, you could kind of see from the slide, minimum cost effective potential, passive program potential, but actually the bottom line for this, it showed that potentially we could get 45 billion gallons of water a year if we actually achieved that potential for water conservation. So this next slide I'm going to show, and why do I show this one? It showed that this washer rebate was something, it's a piece of low-hanging fruit, that if we increase the rebate, we could get a lot more conservation. It would make a difference for us. So we increased the rebate from 300 to 400. You could ask, okay, so what else do we have? Of course, landscaping is another big area that has a lot of potential. So that's something else that, of course, when you see programs going forward, we're going to be looking at landscaping because that's another area where we could get additional water conservation bang for our buck. Okay, recycled water production, so that shows a map of the city of Los Angeles, but it also indicates, as Tracy was showing, okay, where are the different recycled water treatment facilities, the sources of supply for recycled water. So we have in the valley, there's Donald C. Tillman. We also have, of course, Hyperion, which is close to the coast. We have LA Glendale, which is in the center. And we have the TI plant, which is down in San Pedro. You see actually the counting plant also, you could see a little bit north of where TI is. And when you see those purple lines, the purple lines designate purple pipe. And so that's where our purple pipe for distribution of that recycled water has been constructed. The pipe that's where the lines in green show the pipe that we have has potential to be constructed for additional purple pipe distribution or recycled water distribution. Okay, so I think Tracy went through this, so I'm not going to go through it. But this is pretty much the treatment of recycled water, but we just put this slide in there just to show pretty much, as I'm sure most of you know, that it's a multi-barrier process. It's a multi-step process. Pretty much it's to ensure the preservation and protection of health and the environment as we treat the recycled water. Because as Tracy said, we go out and we talk to people about the use of recycled water, and there's the assurance that we do everything with this treatment process. Tracy does everything with the treatment process to make sure that we have protection for the people, protection for the environment. And this is for tertiary treatment. It's for non-potable reuse. And of course, this is just a slide that shows, okay, this happens to be the Japanese gardens and DCT, recycled water, soccer fields, golf courses, use it for dust mitigation, street sweeping, so many types of uses. Okay, stormwater capture, we talked about stormwater capture, but the big thing for us for stormwater capture is basically it's a way to recharge, of course, our groundwater. I showed this slide about groundwater. I'll talk about groundwater as we go forward, but stormwater capture gives us the opportunity to basically recharge our groundwater, and it does so in an environmentally, sustainable manner. So let's see, when you go through stormwater capture, we did a stormwater capture study back in 2017. So we looked at the current capacity for stormwater capture for the city of Los Angeles. It got 65,000 acre feet annually. Okay, so we looked at the capacity goal for 2035. That actually over doubles it. It's 150,000 acre foot a year, which is doubling it. So it says capacity goal because people say, okay, so obviously I wish I could stand here and say I could control the amount it rains, then I could control the amount, hopefully, of stormwater capture, but of course I can't say that. So that's what we say capacity. I think Mark said we got 5.5 inches of rain or 5.3 inches of rain in the last 16 months. Okay, so how much stormwater did we get? Not too much. But of course, if we look 2 years ago, we had a lot more. So that's why this is a capacity goal. And actually, on the slide, if you're interested to look at what we have in terms of stormwater capture master plan, you could go look at it and just on our website, so you could take note of it. Okay, so this one just shows pretty much stormwater capture, basically all the benefits of it, that improves water quality because you're not putting the storm water untreated to the ocean. You improve groundwater quality. We're able to reuse it, of course, because it's being spread on our groundwater basin. It's just a good environmentally and sustainably thing for us to do. Okay, so this is, I think, the fourth chair, not the fourth chair, the fourth peg of the stool. And so this shows our San Fernando groundwater basin and why it's so important to us. It just basically our source of groundwater supply, pretty much we get almost 80% from the San Fernando groundwater basin. And so you could see this. Okay, you look at the water rights. So the entirety of our water rights is almost 110,000 acre feet a year. So San Fernando, we have 87,000 acre feet, which is a tremendous amount of water rights. So that's something, of course, it's a great source of supply. It's local, and so that's something that we're very anxious to preserve and very anxious, of course, to use. So what's happened with that, of course, over the years since the 40s, the groundwater basin was contaminated probably by industrial usage, and so it's not a pristine water basin. So we pretty much said, okay, we can't wait, and I think Mark said for Superfund, we can't wait for them to clean it. We have to pretty much start. We're losing wells because we can't pump them due to contamination. So we have to actually go ahead and start planning for the treatment itself. So our first treatment facility of our wells, we have construction starting in September 2017. And so we have two other actually centralized treatment facilities, which is Tatanka and North Hollywood. Those, hopefully, we've got through these are two milestones that have to be up here, which is remedial investigation feasibility study, because we are still trying to pursue compensation for the pollutants for this, for the responsible parties. So those public comments periods have finished actually in September and October of this year. So that was a big milestone for us. Also, it shows that we're actively pursuing outside funding. And so to date, we have $51 million for these particular projects. And we hope to get more. Okay, this just shows, okay, everybody's happy because this is the first project that we ended up breaking ground on. So that was September of 17. Okay, now groundwater replenishment. What are we talking about? That's when we take the water from Tracy, or I should, her plants, and basically we take them, convey them, and instead of just stormwater for replenishing the groundwater basin, we pretty much take that water to also replenish the groundwater basin. And so that's another source of supply. It's going into the groundwater basin, which is very important to us. And we will use extraction wells to take it out, treat it, and then distribute it through our system. So that's very important to us. That is something, the initial phase, as Tracy mentioned, is 3,500 acre feet. And this is something that she also talked about, that we're going through some ozone treatment, actually, when we do this. And we actually spread the water, there's soil aquifer treatment, because that's an actual process where pretty much the microbes in the soil break down all the organics, and you get something, of course, a clean set of supply. And of course, it goes to our aquifer, which we can then, of course, use for groundwater. Okay, just to end this, okay, I guess it's the 4 pillars of what our supply is in terms of local supply, water conservation, which is, of course, demand-side management, the recycled water, which we, of course, are working closely with LA Sand, stormwater capture, and, of course, the replenishment and remediation efforts that we're going forward with. So with that, thank you. I appreciate it.
So we're a little bit over time, but I think we have some time for questions. And I know we have folks up here anxious to answer your questions. So please stand up, tell us your name, and ask your question.
Hi, my name is Naseem Golestani. I'm a Master of Public Policy student at UCLA. My question is, what's the greatest, policy or political obstacle that we currently face in order to kind of reach our water conservation and water resource management goals?
So I think Mark's going to start.
Yeah, why not? I think the focus, unfortunately, is probably number one is money. And so you've heard a number of speakers tonight talk about the importance of Measure W, and it really can't be underestimated. Stormwater is something that's been a requirement under the Clean Water Act since 1987. There really hasn't been much in the way of funding that's gone to it that's really been dedicated towards that. It's very difficult in the state of California because of something called Proposition 218, which means you need a 2/3 vote of the public to increase fees to pay for stormwater and flood control. That has been a huge constraint from the standpoint of looking at stormwater as a water supply in the way that it should be. And we have not seen reform of Proposition 218. It's been promised by Governor Brown. It just never happened. And so that's why this Measure W, LA County, I'll tell a quick story. I remember getting yelled at, and now he's on faculty here, this is why this is so funny, by then supervisor Zev Yaroslavsky, who's now in the Luskin School of Public Policy, way back in 2006, because I was the chair of the Santa Monica Stormwater Measure campaign, Measure V, and saying, like, how dare you go ahead and do this? LA County's going to do this next year, meaning in 2007. Now, clearly that never happened, and the reason it never happened is because politically it's so difficult to really get people to back a tax. And so that's why this is really tough because of this 2/3 vote. That being said, the other mechanisms we have for payment back in, when I was just starting out in the field and even before, the federal government used to pay for upgrading of wastewater treatment plants to get to water recycling plants and really make large investments. We don't see that anymore. The investment from federal government in infrastructure has really plummeted dramatically. And so trying to pick that up at the state and local level is a very difficult burden. And so we're trying to do that through water bonds as a state, but those things pretty much turn to be very political, and like whoever can lobby to get their project in early when people vote often has a distinct advantage. It's not, the dollars are never used for highest and best use overall within the state of California. It doesn't mean occasionally they aren't, but not as a whole when you think about the $25 billion that have been raised. So those are some of the biggest things. The last thing I would say is governance, which is, we all talk about how we want to focus on local water. We want to have a one water approach. There's some constraints to doing that. In the LA region alone, we have 200 different agencies that manage water in some way, shape, or form. That makes things very, very difficult when you really are talking about one water agency from the standpoint of managing every aspect of water, from flood control to water quality to water supply, wastewater, stormwater, et cetera. And so the governance issues get very, very difficult. Those ones, believe it or not, may even be harder to solve than the funding issues. But that's why I'm so excited to see Met step in potentially. That sort of partnership, if that happens with the regional reclaim, I think really is going to set the bar on what can happen as opposed to what has happened in the past.
One thing I would add, and I agreed with what Mark said there, another aspect is the policy that the state has on various issues can be very influential in the decision-making of local water purveyors. If you imagine you have a board that manages a water purveyor, and they're responsible for setting the rates to cover the costs of that agency, and that water purveyor decides that they want to invest in a higher cost supply to diversify their portfolio and become more reliable against a whole myriad of challenges in the future. They invest in that supply, then they have to follow on and increase the rates to be able to pay for it. And the folks that are on that board are going to face challenges with their own constituents because they supported the higher rates to pay for it. But it's all good. Now the state faces a statewide calamity like a drought, and they decide to come in and change the game on every water purveyor by saying everybody gets cut back a uniform amount because we're in an emergency and we all want you to comply. What that water purveyor that invested in that supply now faces is that they may not get the reliability benefit from that supply anymore, because while they might not have to call for the same level of conservation that the state is asking for across the board in an emergency, they're thrown in with everybody else. That's what happened in 2016. And that policy, the state board that promulgated that was in a really tight spot. They had to do something. They didn't have uniform information from agencies throughout the state. They didn't have real clear vision in terms of what real reliable supplies were that agencies had. So I'm not putting that at their feet. What I'm trying to say is that those kind of policy decisions have a very real impact and a long-term impact in terms of the way that agencies would think about making investments. It calls into question whether you'd make that kind of an investment at the risk of spending a bunch of money that doesn't get you the benefit that you thought you might get given the previous policies.
Unfortunately, it showed that voluntary didn't work, and that's why you ended up having mandatory, because there was a trial.
That's part of
for a
what
year
led
and
to
a
that.
half
Sure.
led to that.
Other questions?
In the back and then here.
I just had a question for.
Your name, please?
My name is Anthony too. I'm from LADWP, and I had a question for Dan on Measure W. And the question relates to sometimes the political fighting that I hear about. Everyone seems to think that when a bond is passed or something that our legislators can use the money on things that they have not said they're going to be for. Is all the money for Measure W guaranteed to go, as you stated, towards stormwater quality and water supply benefits to local areas?
Yeah, in fact, yes. There is built into the program a significant amount of oversight, including mandatory audits that are going to be conducted by a third party to ensure that the dollars that were distributed were actually spent in compliance with the program objectives. So there is discretion on which projects get built, but what those projects do and how they contribute to cleaning up the stormwater and contributing to water supply are mandatory elements that must be present in each project.
You can't even get a project approved unless it meets a minimum criteria, and so that's something that was really important in criteria development. The other thing to add to something Dan said earlier, which I think is so unusual for a local measure, 90% of the revenue generated within your watershed stays within your watershed. And I've never seen a number that high for any measure. And so that deals, your question and the comment I just made deals with pretty much the number one sorts of concerns that are often brought up.
Question up here.
Oh, hi.
Up here first.
Hi, John Dorsey, Loyola Marymount University. What do you think it will take ultimately to get to direct potable reuse?
I think it's going to happen, and I think it's going to happen. You know, the number one thing, obviously, is the State Water Resources Control Board needs to make a recommendation on what the regulations need to be that allow it. The Blue Ribbon Task Force report that came out about a year and a half ago, you know, John, you know me really well. I wanted to tear it apart. It was really good. You know, I mean, I really think they took a very public health protective approach in what they recommended in ensuring that there would be a buffer. And so now it's in the state board's court. You know, I think what would force the issue, going back to some of the things that have been talked about by Devon and others, is that, you know, I mean, if the state legislature wants to catalyze this in any way, shape, or form, I think that would help. They haven't done that yet. It's pretty much like this is on the docket to pretty much for the State Water Board to come up with recommendations. Do you remember, 2 years from now? Something like that? Yeah.
5 years. 5 years.
5 years from
2023.
Is it 2023? And so then the question will be, once they make the recommendation, whether that actually turns into a reg and how quickly that'll happen. But, the more there's, a background, support to make that happen, I think the more likely it's going to occur. I think it's inevitable. I predict by 2028 to 2030, it'll be legal in the state.
I would agree with that. Regulations, or actually legislation, was just passed last year requiring that direct potable reuse regulations be adopted by the state board by 2023. There's a compendium of types of DPR, so it's not the flange to flange. That's a big reach because you do need environmental buffers, and when you do flange to flange, you won't have that. But the lower levels of DPR, certainly the regs are in place, and I think that once those, or they're under development, and once they're in place, it's going to make it a lot easier for utilities to actually move forward with projects, because we'll know what the expectations are and what the requirements will be.
I'll just add into that it's being done at Stone Brewery in San Diego. So, Miguel Gasca.
Your name, please.
That's what I was saying. Miguel Gasca. I'm on the board of directors of Rainbow Municipal Water District in North San Diego County. And it's real simple. I'd like to get a copy of everybody's charts. There's a lot of good info in there that I'd like to bring back to my board.
I'm Dave Jones with Hazen and Sawyer. A question for Tracy and/or Susan. So I noticed in Devon's presentation he had a pipeline going across connecting to Weymouth and a form of DPR. So when what about the city of LA? Where's the pipeline going to be?
Okay, that was a pipeline question, so that's for Susan.
Okay, so his was going to Weymouth. Of course, we have one big filter plant, so if we put a pipeline, it'd be going up to our filter plant, which is in Somar. So that's something, of course, that we've talked about. So who knows? I'll leave it at that.
I think it's fair to say that from our perspective, there is even if you had direct potable reuse regulations in place now, there is a significant benefit to the groundwater basins that we're seeing. So you still want to try to structure something that's leading to a benefit in the groundwater basins. The storage levels are declining. In one way, it could be through in lieu. So if you had DPR in place, you could meet the overlying demand with that water and then maybe relax off the basins a little bit. So the graphic that I showed you was conceptual in terms of how it could apply down the road in terms of getting it to the headworks of another treatment facility, which to Tracy's point is not flange to flange, but is yet a grade lower in terms of direct potable reuse in that spectrum.
One more question, please.
Thank you. Simon Bluestone with Stantec. Quick question, Mark. You talked about governance structures and challenges and the financing as a challenge. I'm curious for the whole panel if you think there's any viability with enhanced infrastructure financing districts as a mechanism to fund these sorts of projects. I know there's a lot of discussion at the moment with the Los Angeles River and the city of LA, and there's been some discussion around these alternative or innovative models that can bring multiple entities together, special districts, cities, counties, and create a separate governance structure.
I think that's a really good question. I think it's something that we took a look at in the report for the city, and it's one of those things where I think because it's so unproven, it's hard to know really how much of a benefit it really could be. The potential to to really do that and really, to get some sort of, ongoing economic benefit through those sorts of districts, and have the district be large enough that it's going to generate revenues to really make a big difference. It seems like it's there, but it's kind of astonishing to me. I remember when they became legal, that the thought was, hey, there'd be a bunch of these things that would start proliferating throughout the state. It's gone really, really slow, and I would almost throw it back to you from the standpoint of, why do you think, if it is supposed to be such a good tool, why is there such an enormous reluctance to use it in a significant way on water? I know there's been a couple that have occurred for various different other purposes in the state, but we just haven't seen anything big on water. And it's one of those things that sort of harkens to, oh, let's fiddle with the words a little bit to redefine stormwater, and maybe that'll give us an end run around 218. And nobody's done anything to try to make a run at that either. The county actually, their county council said, too risky, we're not going to do it. And so I'm just wondering whether, someone's got to take the bold step of going first and demonstrate really what the value of these things are before doing that. We haven't seen enough creative financing in that regard, and I think that's really what you're pointing to.
Real quick, one thing I would say. This is the shameless plug, okay, of the evening. Metropolitan was originally an innovation in finance. The reason that we were brought into being was to provide the financial backing for a major project that a city like Los Angeles or a few other small cities thrown together couldn't do on their own. And it's the same logic that is providing the backdrop for us considering the regional project that I described before in partnership with LA County Sanitation District. So it's the notion that if it's at that kind of scale, we can come in and ensure that it provides a regional benefit, which then allows, through us, a regional payment mechanism.
Well, we've had a lot of interesting questions and a lot of interesting answers. I think Mike Selma is going to summarize a few things and make some concluding remarks.
Actually, I'm going to get us out of here. So we started with a question. In this time of climate uncertainty, is Southern California ready to invest in sustainable local water resources? And I think we have answers. I think each of the presenters did an excellent job of presenting a comprehensive overview of where their agencies are headed in this question of providing sustainable local water resources. And I congratulate each of you on your fine presentations. Thank you very much. One minor thing, we have each of your email addresses, and we're going to be sending you a short survey, 2 or 3 questions about this event. We use that in planning next year's event. Last year we had a lot of feedback, and it resulted in this fine program. So I hope you'll look for that and participate in it. And we thank you very much for getting yourselves here through traffic and during the evening. And we look forward to seeing you next year. Thank you.